This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Now let's try to be fast. We are back for the third lecture today. We are going to see the for loops. I'll try to cover at least 3 examples with for loops and strings together. And afterwards, I hope we will have time to show what are you going to do for your homework. So please remind me for the homework if I forget. For loops, very briefly. This is another loop. So just remove the old stuff we had. And before starting, first let me introduce to you with the for loop. This is how for loop works. The initialization of the loop starts here. You have something initial here. Then you have the condition here, which is like the while part. Is it true or false? Divide.
By initially, you mean like the start of the counter and stuff, right?
Yeah, that's if you want to multiply it 100 times. Initially the counter is 1, okay? The initial value of that counter. You have the condition here, which is same as the condition of the statement that you saw in if and while loops. And you have here what? A command which is going to be executed again and again. So let me give you a clue. You had the while loop. The condition is this one. Inside the while loop, for instance, if you want to multiply numbers hundreds of times, the counter is incremented inside the while. Counter plus plus. You can do it right here. I'm going to show it with codes, and you will see it, how it's working. So let me put existing item, the source that we already saw. So this is the source that we wrote previously. Now, let's start with the multiplication. Finding the product of numbers from 1 to n. You remember this function. If you want to write this in terms of for loop, this is what I'm going to do. So this product is going to stay here. In product, we always have 1. But the counter is going to be here. So you can define integer, counter. Initially the counter is 1. Okay, so this counter, the initial value of the counter comes here. Then we have semicolon. Afterwards, the condition of the while comes here, semicolon. And you see, in the end, the counter here of the while is incremented after each loop. So we have it, we put it here. And what do we have inside the loop, the for loop? We have this part. The product is equal to the old product multiplied with counter, or it can be written as product multiplication equal to counter. It's the same. Okay? So, how the for loop works. This part here is executed only once. Okay, you see this one is executed only once, and this one also. Okay. Afterwards, we check whether this condition is true. If this is true, then I'm executing it. When this is finished, I go here and execute this counter plus plus. After executing counter plus plus, I check the condition. If this is true, I go again, I execute this one, then go check the counter. If this is true again I go here, execute this one, go to the counter, increment it. Check the condition, execute the command, increment the counter. Okay, this is how it works. So after finishing the for loop, we execute this command here. In our case, it's counter plus plus. We check the value. If this is true, this condition is true, we go inside. Okay. I intentionally put both of them here so you can compare both the for and the while loop,
So they both do the same thing, right?
they are doing exactly the same thing. Okay? So that this while loop is doing the same thing as this for loop here. Okay? Exactly the same. Again, this part here is executed only once in the beginning when we initialize the for loop. Okay, that's why we say this is the initial command. Initially counter is 1. And we want to multiply, we want to find 1 multiplied by 2, by 3, by 4 till n. That's why we increment it and see whether we have reached n, the number we've given. So multiply, increment it. Is this smaller than n? Yes. Again, smaller than n, increase it. Is it smaller than n? Yes. Okay? If you don't trust me, we can just write something like this here. If there is no logical mistake, with while the product is okay, find the product from 1 to n. So the product is okay. So again, we should find the average and the standard deviation very briefly. The formula of the average is the following one. Maybe we should show the board. Yeah. Okay, we should find the average between x1 and xn. So the average is this stuff here, divided by n. N is the number of numbers that we are summing up. We can write it like this: the summation of xi divided by n. This is the average. The standard deviation, so if x is 10 and y is 20, or x1 is 10, xn is 20, we sum up the numbers from 10 to 20 and we divide it by how much? 10 or 11? We have 11 numbers from 10 till 20. Okay, we divide it by 11. This is the average. The standard deviation deals with the following part. Not all the numbers are 15 because we have 14, 13, 16, 17. So the standard deviation basically is telling on average how much they differ or are dispersed from the average. The formula is the following one. Here. So x1 minus average square plus x2 minus average square. Basically, we can write it in form of the summation in this manner, divided by n. This is standard deviation squared. In order to find the standard deviation, we just find the square root of this term here. For this reason, we are going to use two math functions from the library math-h. One of them is power. It takes two parameters, a and b. They can be integer, double, and so on, okay? Because we have multiple power functions defined inside the math library. It works in the following way: a multiplied by b. This is the value that the power returns. For instance, power 3, 2 is 3 squared, which is 9. For the square root, we are going to use the sqrt function of the math library, okay? And again, let me show you the output again. Average standard deviation. So from 10 to 20, the average is 15, and the standard deviation, the dispersion of the numbers from the average, is 3.16. Meaning that, on average, from 15, between 10, on average, they are dispersed for 3 numbers on the left, and on average, they are dispersed for 3 numbers on the right, okay? This is how it works. Now, you should write some piece of code in your own. Obviously, we are going to use a function which is called average. We find the average between x and y. How we are going to do it? The formula is obvious. First, we should find the sum of numbers between x and y. That's why let's find the sum. Initially, when we find the sum, we initialize the sum to be 0, as we already saw it. And we saw the example when we started from 1 to n. Now we start from x to y. That's why the initial value is x. Okay. We are checking whether x is smaller or equal to y. If this is the case, yeah, it's true. And we have x plus plus. We are increasing x at each loop, at each iteration. This is called iteration. Iteration means going inside this block for once. If we go inside and execute the code in this block, it's called one iteration. Another, third one, and so on. Yeah, questions?
So increase I of that.
Oh yeah, I'm sorry. We should increase I. You're right. Yeah. We're increasing I. X is X. So the sum is equal to the old sum plus I. Okay? So I is going to be X, then X plus 1, X plus 2. You can write it in a better way like this. Sum plus equals to I is the same. We found the sum. Now, in order to find the average, we should divide the average with the number of numbers we have between x and y. So, how many numbers do we have between x and y? Y minus x plus 1. Exactly. So, let's say x is 5, y is 10. From 5 till 10, we don't have 5 numbers, we have 6, okay? 5, 6, 7, 8, 9, 10. So, count, let's define another variable which is called count, is equal to y minus x plus 1. Then let's define a double variable which is the result, and the result is equal to the sum divided with count. This is it. And of course we should return this double. So return double. This is how average works. Return result. Now, we have the function called standard deviation, which is calculating the standard deviation. Again, here I'm not going to... Do you want me to go through the codes or not? If you understood the formulas on the board, you will have easy time understanding this code. The count is, again, the number of elements between x and y is count. By the way, the standard deviation as parameter takes x, y, and the average. Because you see the formula there, we're going to need the average. So the count is this one. Sum of the variation, the standard deviation initially is 0. And the deviation, the result that we are going to return, should be 0 initially, but we are not going to initialize it for the time being. We will see. We are going to find it. We define an integer variable I. We are doing the same thing. From x to y, we increment I by 1. Sum of variable of those single terms. It's sum of var plus power of I minus average squared. Basically, we are doing, with that part of loop, we are finding this one here, okay? xi minus average squared. This is xi minus average squared. This is the power function, and we are adding it. This is the summation. After we find the summation, we divide sum of the variation of the dispersion with count. It's going to be a double, but remember, the variation, the standard deviation, it's called a variation also. The standard deviation is the square root of this sum here that we found, divided by count, the square root of all of that. So we find the square root of that, assign it to the DEV variable, which is of type double, and we return the DEV. SQRT is also part of math pointation. Is this clear? Yes or no? It should be. In main, we're doing nothing special. In main, we just define x, y, two double variables, average and standard deviation. We are printing blah, blah, blah. This program is doing this stuff. We are entering two numbers. And this is the part that you asked. If x is smaller than y, then we are finding the average of x and y and the standard deviation of x, y, and the average. Okay. Otherwise, if y is smaller than x, we just swap those places. We're finding the average again. yx, and average. Okay. So if I give 10 for x and 5 for y, we are calling it 5, 10 again, calling the function 5 and 10. The average returns the average, the standard deviation returns the standard deviation, whatever the case, and we are printing them. The average is this much, the standard deviation is this much, and this is it. Okay? Any questions? Is this clear? If you have questions, please raise your hand. Now let's go with another example. Punctuation. So we are removing this one. Okay. By the way, you will have the solutions. I mean, you even don't have to write anything. So punctuation is here. I'm adding it. Let's see what this guy is doing. See and ignore. Basically, here we want to find whether a certain string that we're giving as an input has punctuation signs. Namely, there are a lot of punctuation signs. We are checking for those 6, okay? Full stop, semicolon. How do you call this in English?
Full stop.
No, this is full stop. The other one? I don't know the name. Okay, question mark, comma, exclamation mark, and so on. If we find only one of them appearing at any place of the string, the result is true. That that particular string has a punctuation sign. Otherwise, it doesn't have a punctuation sign. Let me check. Let's see the output of this program. So, if I'm saying something like this, Artrim, do we have any punctuation sign here? Comma, full stop, whatever? No, we don't have it. That's why there are not any punctuation marks in the input string. However, if I run it with the following input, there are punctuation marks. It can be at any place. I mean, I can do even something like this, comma. Still there are punctuation marks in the input string. Okay? So, how am I going to do this? Very simple. Just let's understand this function, the check punctuation function. This function as a parameter takes a string. It's called word inside. Initially I say that, well, I don't know. I define a Boolean variable which is called result. And initially I said that this result is false because I don't know whether there are punctuation signs. I define a variable I, and this variable I will help us to iterate through the string and check each character of the string one by one. So let me clear the board. Let's say that the word that I've given as an input is the following: A-R-T semicolon R-I-M. Input that I've given to the check punctuation function. The name of the variable is word, and I want to see whether I have a punctuation sign, namely one of those signs, at any place in this string. Again, we start from 0. This is 1, 2, 3, 4, 5, 6. Meaning the length of this guy is 7. Okay, we even don't take it as a parameter. So let's see how it's going. I have a result of Boolean variable, a variable which is called result. Initially it's false. Now, I'm starting from the beginning, okay? Let's say the word that I'm passing as a parameter is this one. Now I'm starting from I equals to 0. I'm defining another variable, I. Its initial value is 0. And I iterate, go through each character one by one. This is done with this for loop. So again, I'm doing the initialization part here. I is equal to 0. I put I to 0. Then I'm checking. Is I smaller than word point length? What's the length of the word? It's 7. Okay. Is 0 smaller than 7? Yes. Then I'm going inside and I'm asking, is the word at 1 equal to this? So the word at 0, is that equal to exclamation mark? No. Or the word at 0, is that equal to question mark? No. Or, and so on. This is the or function. Meaning, only if one of them is true, this if clause, if statement is going to be true, and the result is going to be true. Okay? So, is any of them true for the first? No. That's why this if is not going to be executed. We come here, we go to the beginning. We go here, increment I by 1. I plus plus, meaning I now is 1. From 0, it becomes 1. We go inside. Is this going to be true now? R for index I. I is 1. R is in the first position. Is this going to be true? No. Because R value is not a punctuation sign. That's why this is not going to be executed. We go in the beginning, we increment this by 1. I is becoming 2. Is 2 smaller than 7 than the length? No, it's not. We go. Is T any of those? No, it's not. Again, I becomes 3. Now we are checking. Is 3 smaller than length? Yes. Because this is true, we go inside the for loop. Now we are checking. This is going to be true. Yes or no? One index is 3. Okay, this is word. So this is 0. T is 2. Semicolon is 3. Word at 3 is how much? Okay, this is the word. Word at 3 is how much? It's what? It's semicolon. I mean, at with... Yeah, it's punctuation sign. So this is semicolon. That's why if we check, if word at 3 is equal to at I and I is 3 is equal, is that equal to exclamation mark? No, this is false. This is false. This is false. This is false. But this is going to be true because we have the or statement here, the or logical operator. This is going to be all if is going to be true. So we go inside the loop and say, well, the result is equal to true. So from false, we make the result be true. Okay? Now we come out of the loop, we increment I by 1. It's going to be 4. Now, we are going to go to the upper, it's going to be 4, 5, 6, 7. When it's going to be 7, then we are checking, is 7 smaller than 7? No. Then we are going outside and we are returning result. Okay. And the result is true. So this is what are we returning. We are returning a Boolean value. You see that the return type is Boolean. Okay. Now, is there anything missing with this function? Is this a good way to do this function? Because you see, we found the punctuation sign, and what if a string has 1,000 characters, and the punctuation sign is at the third place, at the third index? We have to check like 900 and blah 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 more characters. But we don't have to because we want to find only one. We have found it and we are just wasting our time checking others. Do you agree with me? Okay, so we found that the punctuation sign is here, yet we are still continuing with the for loop.
Yeah, but it's an if clause.
Yeah. Even if we have other punctuation signs, it's going to be again true, 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 true.
Yeah.
It's never going to be false, but you're wasting your processor time.
Like the OR operator, and if the OR operator finds one true result, doesn't it just automatically assume that it's true and like discard the rest?
In this case, yes. But is this a good way of doing things? I mean, if you're asked, you have a big string, you're asked to find one punctuation sign. Are you going to check all of them till the end, all the characters? Just imagine, I mean, you have Artrim, and you have like 1,000 more characters.
You don't know where the punctuation is.
Yeah, let's say that you found it. You don't know it. Let's say you found it. It's here. Are you going to check all of them, 1,000 still?
No.
No? Yeah, you're not going to check it, definitely. But this program is checking them. Yeah, it works correctly, but it is wasting our processor time. And we don't want to do that. As an engineer, you try to finish your job as soon as possible, okay? It's like we're giving you assignments, you do the job of the assignment, you say, okay, let's do something more. You're not going to do that, come on. This is the same thing here. So how can we change it here? So we don't have to check it again and again. Basically, if we find that there is this, I'm giving a hint to you. If this result is true, then I don't want to check it.
So you say as soon as it finds the first
Yeah.
item, you can issue like a stop command or something?
And what would that stop command be? One of the ways of dealing with this stuff is you want to return true or false. You can return true here, okay? But I told you, this is a very dangerous way of doing programming. In this case, yeah, I mean, it's obvious. But sometimes it's not obvious. Sometimes you want to have the return stuff at the end, okay? So you want to do something like this. If I have found a punctuation sign, I don't want to continue anymore. Meaning if this result is true, I want to check, and we are going to the second check, okay, if the index is smaller than the length, okay. And I've not found a punctuation sign, then I want to go inside. Otherwise, if the index is small, greater than length, or if the index is, or if I found a punctuation sign, I don't want to repeat this loop. So how are we going to do that?
When it finds punctuation mark, you can set the index to the, what's it called?
Yeah, very nice. I mean, you can say that index is equal to the length. You can do it, very nice. So basically your friend is saying like this. You can set the index, I is equal to word point length when you find one punctuation sign. And when you're going to check this one, or increment the index, is going to be even greater than the length. And you're asking, is this more than the length? No, it's not. We're going out. Yeah, this is very nice. One way of doing things is this one, but also, this is what I'm trying to do. If I have not reached the end, and I'm writing n like this, I have not found a punctuation sign. How do I write this? If I found one, if I've not found one, if not found is written like this. The result initially is false. This negation makes it true. So if I have not reached the end, and I have not found a punctuation sign, the result is false, then go inside. Result is initially false. This negation makes it true. So true and true makes true. This is logical end, and I go inside, okay? So you have, I mean, maybe you are not asking this kind of things from you now, but you have to think it in your later life as a future programmers eventually. If you understood this function, the other part is trivial, easy. Any questions? Okay. Unfortunately, we had 2 more examples to cover for today, and we are going to cover which one? Only one, and try to be fast. The consecutive vowels. And I hope I will have like 5 minutes to deal with your homework. So just add consecutive vowels. Consecutive, do you know what does that mean? Back to back. In Turkish you say arka arkaya. one after another. So consecutive vowels, I'm adding it. Okay. Let me show you the demo, because we should write some piece of code here together. This is what your program should work. You should give a string as an input. Let's say I'm giving hello. Vowels are E and O only, okay? You know, consonants and vowels. So H and LL are consonants. We have two vowels, but they are not close to each other. Not one after the other, okay? That's why we have the result. The string hello does not contain consequent vowels. If I run the program again and I say good morning, we have O and O, both of them are vowels and are close to each other. So the string good morning contains consequent vowels. Okay, so how are we going to do this stuff? Because we don't have time, I'm just going to give you the algorithm, meaning the logic behind it. And I'm going to write the code for this function. So this is the string or the word that we want to check whether it has consequent vowels. Its name is going to be S. It's like this. Let's say we have the good morning stuff. Or only, good morning. I'm going to do it this way. I'll start from G and check whether this is a vowel or not. If this is a vowel, then I'm going to define a new variable which is called isVowel, and I'm going to make it true. I have another variable called consequent vowel. This is also of Boolean type. So this is how it works. Initially both of them are false. This is false. This is false. And I start from the first index 0, 1, 2, till the end. I go to the end of the string and check. Is G a vowel? No. If it's not a vowel, I'm not going to make any checks either. I'm going to O. Is O a vowel? Yes. So this is going to be true. And if this is true, I'm going to check, okay, this is true. Let me start from scratch. Okay, this is true. Now I'm going to this one O. If this is a vowel, yes. If this is a vowel, and if the previous vowel is also vowel, then consecutive vowel is true. Okay? So if I find a vowel, then I check this part here. If this is also true, then we have two consecutive vowels one by one. Do you understand me? Okay? Again, I start with G. Initially everything is false. And I say is G a vowel? No, it's not a vowel. Okay, go on. I go with with O. Is O a vowel? Yes, this is a vowel. Now I want to check whether the previous one is vowel, whether this is a vowel, is true. So this is yes. But this one is false. That's why this is going to be false, but I'm changing this one to true. I found one. Now I go here. Is this O a vowel? Yes. If this is a vowel, I'm checking this one. Is this a vowel also? Yes. If this is a vowel, then we have two consecutive vowels, and this is true. Okay? This is the logic behind the code. I'm going to write the code here. Okay? And how many vowels do we have in English? So we start from 0 up until the length of the string. So I is smaller than S length. And we increment the index by 1. And we ask if not append S at I is equal to A, or, because these are vowels, is equal to O, or it's equal to I, or it's equal to what's left? E, something else left? U. Okay, if this is true, then what we are trying to do is the following. We have found a vowel, and we are trying to check whether the previous one is vowel. So if is vowel, so we are checking if is vowel. If this is true, the previous vowel was also vowel, then very nice. Consecutive vowel is equal to true. Otherwise, if this guy is a vowel and this guy is still not a vowel, what we are doing is the following. Else is vowel is equal to true. Okay. Now, there's another, you might think that this is working, but we want consecutive vowels, one by one. That's why if we are doing the check here, if we are doing the check here, and if it's not a vowel, so this else goes for this if here, then we are saying that is vowel is equal to false. Okay? Let me make it clear here. Maybe we should record the board now. Why did we add this part here? You might find this, strange. So, initially, we don't have any vowels found. False. False. Let's say that I'm using the string hello as an input. Now I'm checking. Is H a vowel? No. If it's not a vowel, none of those cases apply, then I'm saying is vowel is false, but it's already false. Now I'm going to the next case, and I'm checking, is E a vowel? Yes. Okay. That's why if E is a vowel, I'm checking this part here. Is vowel set? No, is vowel is not set. It's false. Since is vowel is not set, I'm going here. Is vowel is equal to true. I'm making it is vowel to true. Meaning that I found one vowel. Now I'm trying to go to the next one. Is L a vowel? No. That's why I'm going here and saying is vowel is false. Okay? Because if I didn't set it to false, if it's true, eventually I'll go to O. O is a vowel. Then is vowel is also true, and I'm going to make the consecutive vowel false. But they're not consecutive. They're not close to each other. Okay? That's why if I find something that's not vowel, I'm setting is vowel to false. This is why we wrote this line here. And the program is working. Okay, you might have double this here. So if you find consequent vowels, you want to finish the program, and you can do it in the same manner that we did it previously. You remember, okay? Meaning that you can put here, if the length is smaller, and if I have not found the consecutive vowel, then repeat this loop again and again. Okay, this is the last example for today. I'm going to show you only the homework. We had another piece of code, but I'm afraid we don't have time about it. So your homework is due to next week, Friday, so you have like 7 days, 8 days or so. This is what you should do. And you should not, you are going to use loops, whether it's going to be while or for, it's your decision. You are going to use strings, meaning for the strings you will need only add, find, substring, and so on. Let me tell you some sample runs, what they are about. So you give a pool of words, and they finish with this sign, with add. This is your pool of words. And you're trying, this is your vocabulary, kind of autocorrect. Then you give another word, so you give sal and mal. You have kal, and you try to find whether this kal is similar to one of them. But it's similar to both sal and mal, but they differ only in one place. Like let's say sal, we have S here, we have K here, so spelling mistake is 1, okay? And possible corrections can be sal and mal. Now giving another word, it's al. There are no close matches for the word. Why? Because this word has the length of this word is 2. It has only 2 characters, and we don't have anything with 2 characters. Then we have amatu. It has 4 characters. Words can only include letters. Also, the problem with this one is not the number of characters, but it has a digit. It should contain only words. Again, if we put ama, you see it has 3 words. The length of ama is 3. Both of them are 3, but the problem is that we have 2 mistakes. If the number of mistakes of not matching characters, corresponding characters, is greater than the half of the length of the string, then we are not showing it, okay? Because we have even 3 mistakes here. No one starts with A, no one has M in the middle, no one finishes with A. We have 3 mistakes. Even if it was 2 mistakes, we should have printed this word. There are no close matches for the words, okay? Yala, no close matches. If you press quit, the program finishes. If you write quit, okay, the program is going to finish. Another sample run. This one, Ali, Veli, Giri. This is your vocabulary. And you are trying to find al, but this has 2 characters, so you didn't find anything with al. If you say alda, then you have found it to be close to Ali, and you printed that it's close to Ali, and spelling mistakes is only 1. Meli is close to Veli and Geri. That's why you're printing it spelling mistakes 1. Possible corrections, Veli. Okay? You can print Geri as well, but try with the first one. Also Feri. You can print Geri and so on. Okay? This one has no matching characters because it's no matching words here because it has 5 characters. This one has this character, which is not a letter. We should include only a letter, and so on. Okay, and this is something else. In a sense, you are going to see, you have seen the autocorrect option in your word editor. So if you're going to become a programmer, you're going to see this one. Okay, you have seen autocorrect options. You have misspelled a word, and it says, okay, these are the suggestions in Microsoft Word. So in a way, it's done something like this, okay? So your job will be to do this program. Okay, this is it. See you next week. If you have questions,